Is greater than 20. In this program on measuring instruments, this program has been designed to assist you to understand and practice precision measuring in the engineering field. During this program, you will be shown the basic principles of reading and maintaining conventional metric outside micrometers. The principal purpose of an outside micrometer is to measure very accurately thickness and diameters of precision parts or components. When you are able to correctly read a micrometer, you will also be able to gauge measurements up to 1/100th of a millimeter. But before you start measuring, let's begin by identifying the principal parts of a typical outside micrometer. The main part of a typical micrometer is called the frame. The frame is U-shaped to provide clearance over the object to be measured. An anvil provides a hard precision surface which contacts the workpiece. The sleeve, or barrel as it is sometimes called, has a graduated datum line. Along the datum line are graduations, numbered in 5mm steps. Between each step are the 1mm unnumbered divisions. Each millimeter division is subdivided by 0.5mm submarkings on the opposite side of the datum line. A micrometer sleeve has 25 full millimeter divisions. That is, it has a range of 25 millimeters. To complete our build-up of a typical micrometer, we must add a spindle, which is fitted through the center of the sleeve and is attached to a thimble. Turning the thimble results in the spindle moving toward or away from the anvil. The spindle can be locked with a locking lever, or, on some types, with a locking ring. Many manufacturers fit a ratchet at the end of the thimble. This gives an operator the correct feel and also prevents over-tightening. So then, to recap on the part names, we have a frame with its anvil and spindle lock, a sleeve or barrel bearing the graduated datum line. Finally, we have the spindle, which is turned by the thimble. Having now mastered the part names, we can move on to the practical usage of a micrometer. Adjust the gap between the anvil and the spindle until the workpiece to be measured will fit loosely into the gap. Notice how the micrometer is being held. Turn the thimble until the spindle and the anvil contact the workpiece. Using the ratchet to turn the thimble will prevent you from over-tightening. Use your thumb to lock the spindle before you carefully slip the micrometer off the work. The procedure for measuring round objects is similar, but to ensure that the maximum diameter is measured, use a slight rolling movement as you gently turn the thimble, preferably using the ratchet. Again, lock the spindle and carefully remove the micrometer from the work. When using larger micrometers on large diameter work, move the micrometer up and down, that is, over and back over the maximum diameter. You'll feel gently slides over the workpiece surfaces. No amount of explanation or demonstration can replace actual practice. So, before we continue with how to read a micrometer, let's get in a little practice. Use your micrometer and get the feel of handling it and adjusting it onto various workpieces. Now that you've got the idea of how to feel the action, let's learn to read a micrometer to an accuracy of 1/100th of a millimeter. Earlier in the program, we saw that the sleeve is graduated along the datum line in 5mm steps, and that each step consists of 5 1mm markings, which are in turn subdivided by half-millimeter markings. We then learnt that the full range of readings on the sleeve is 25mm. Now, when a micrometer that has a range of 0 to 25mm is fully closed, the reading will be 0. Notice that the 0 mark on the thimble is directly in line with the datum line, and that the edge of the thimble is aligned with the 0 mark of the datum on the sleeve. This then is the 0 reading. Turning the thimble anti-clockwise will reveal more and more datum line markings. And naturally, the gap between spindle and anvil will increase. Each small division on the thimble represents 0,01 millimeters. That is 1/100th of a millimeter. Turn the thimble by 1 small division, and you have increased or decreased the gap between anvil and spindle by 1/100th of a millimeter. There are 50 divisions on the thimble. Turn the thimble 1 full revolution, that is, say, from 0 right around to 0 again. You will now have altered the gap from anvil to spindle by 50 times 1/100th of a millimeter. That is 0,5 millimeters. If a micrometer was set at 0 and you turned the thimble by 1 full turn, the edge of the thimble would be in line with the first half-millimeter mark on the datum line. This reading then can be written as 0,5 millimeters. It follows that if 1 full turn of the thimble gives a reading of 0.5 millimeter, 2 full turns will give a reading of 1 millimeter. If the micrometer thimble is rotated 50 full turns, the edge of the thimble would be aligned with the 25 millimeter datum mark, and the full 25 single millimeter divisions would be visible along the datum line. It is the visibility of the markings on the datum line that are important when we read the micrometer. Let's explain this step by step. We shall examine this reading as a typical example. First, we count the number of visible whole millimeter divisions. The 10 mark is visible, plus 2 other full millimeters. Therefore, we can write down 12 as the figure before the decimal place. Now, as the thimble has not exposed another full millimeter, but is just exposing a half millimeter mark, then it can be taken that a half millimeter must 5,9/8 millimeters. Now, a lot has been said, and you've been shown the basic principles of how to read a micrometer. So, before continuing, we suggest that you get in some practice using a 0 to 25 micrometer. A good way to start is to measure things for which you can obtain the standard manufacturer's size specification. Objects such as valve stems, gudgeon pins, thrust washers, and so on will be good examples. Check your readings against the given specifications. Practice until you consistently obtain the specified reading each time you measure the object. When you return, we shall discuss some important aspects regarding care and maintenance of micrometers. In this, the final section of the program, we shall discuss some important aspects regarding care and maintenance of micrometers. Remember that micrometers are precision measuring instruments and as such must be treated with care. Wipe the contacting surfaces with an absorbent paper cloth to remove the oil traces prior to using the instrument. Never use force on the thimble. Light finger pressure only is sufficient to obtain accurate readings. A drop or two of light machine oil on the bright metal will reduce the chance of rusting during storage. Don't store the instrument with the anvil and spindle touching. Leave a small gap to prevent corrosion. Give your precision measuring instruments a little tender loving care, and they will serve you faithfully and accurately for life. You can learn more about precision measuring instruments by viewing other programs in this series. In this program on measuring instruments, you will learn about outside micrometers that are designed to measure sizes greater than 25 millimeters. Before continuing with this program, please ensure that you are already able to read micrometer scale readings as described in Part 1 of this program. This program deals with both the fixed and adjustable type of micrometers, which are capable of measuring objects over 25 millimeters. Micrometers known as fixed types are made to read up to 150 millimeters and have fixed handles. Each step up in the range increases the maximum reading by 25 millimeters. For example, the 25 to 50 micrometer has a minimum reading of 25 millimeters and a maximum of 50 millimeters. Similarly, the 50 to 75 millimeter model has a minimum reading of 50 millimeters and a maximum of 75. The measuring range of any outside micrometer is 25 millimeters. Micrometers must be checked from time to time with the setting gauge that is included in every set. This will ensure accurate readings. Setting gauges are made by the manufacturers to an extremely high degree of accuracy, each gauge being an exact fixed standard. Whenever you check the micrometer with the appropriate gauge, grasp the gauge by the insulated section. Do not hold the setting gauge in your hand, as the heat from your hand will cause it to expand and give inaccurate results. Use only light pressure on the thimble. Make use of the ratchet on models that have this feature. Then lock the spindle lock. Now check the reading. The 0 mark on the thimble should be exactly on the first figure of the datum line. Any deviance from exactly zero should be noted and the micrometer recalibrated by an experienced person. It is suggested that you now familiarize yourself with fixed micrometers over 25 millimeters by studying those in your environment. In this section of the program, adjustable external micrometers will be discussed. The important feature of the adjustable type is that anvils are interchangeable and vary in length. Adjustable micrometers are supplied in kits, which include various anvils, setting gauges, and adjusting keys. In 0 to 100 micrometer kits, 4 anvils are provided. The longest anvil allows readings of between 0 and 25 millimeters. The next size down allows readings of between 25 and 50 millimeters. The third anvil permits readings of between 50 and 75 millimeters. And the shortest anvil provides for readings between 75 and 100 millimeters. To change an anvil, simply remove the knurled lock nut and slip the anvil out of the frame. Fit the appropriate sized anvil and, using finger pressure only, tighten the anvil lock nut. To avoid losing any parts, it is strongly recommended that you always place all loose parts into the box. Whenever an anvil has been changed, you should always check the reading standard. If a 0 to 25 anvil is being used, the standard setting should be checked by simply closing the spindle onto the anvil, and then ensuring that the micrometer reads exactly 0. If you are using the 25 to 50 anvil, select the 25 millimeter setting gauge to check the standard. Similarly, when using a 50 to 75 anvil, select and check the standard with the 50 millimeter setting gauge. When using the 75 to 100 anvil, check the standard using the 75 setting gauge. To make minor standard adjustments, use the 2 anvil adjusting keys. One key is used to support the back nut, while the other is used to loosen the front nut. Let's examine a typical out-of-standard setting. In this example, the micrometer is out of standard by 0,04 millimeters. Notice that the thimble's 0 has passed the datum line by 4 thimble divisions. In other words, it is reading low by 0,04 millimeters. To bring the standard back to read 0, we must, in effect, increase the protrusion of the anvil by 0,04 millimeters. This adjustment is made by firstly slackening the lock nut slightly, then, using the key, turn the rear adjusting nut clockwise by a small amount, then nip up the lock nut. Finally, lock up the front adjusting nut against the rear nut. Once more, check the standard against the setting gauge. If necessary, repeat the process until the standard of 0 is obtained. It takes quite some practice to be able to quickly and accurately set an adjustable micrometer to the correct standard. It is suggested that you now practice using the setting gauges to 0 your particular model. Let's now turn our attention to how we can use and read an adjustable outside micrometer. Firstly, the size of the object to be measured should be roughly gauged with a suitable tool. Once you have determined the approximate dimension, you can then select the anvil that will accommodate the particular workpiece. Having selected, fitted, and if necessary, adjusted the standard of a particular anvil, the instrument is now ready for use. You must always remember to include the minimum anvil reading figure in your final reading. For example, if you are using the 50 to 75 anvil, then you must add 50 millimeters to the reading that is obtained on the micrometer scale. Let's now examine two different readings. Firstly, this reading is obtained using a 75 to 100 anvil. First, include the minimum anvil figure of 75 millimeters. There are 18 full millimeters showing on this datum line. Add this. No half millimeters appear after the 18 millimeters mark. Therefore, only include the thimble reading of 0,4. The full reading is 93,40 millimeters. In this example, a 50 to 75 anvil has been fitted. As always, begin with the minimum anvil reading, in this case, 50. Add the full millimeters from the datum scale. That is 6. 1 half millimeter division is visible. So add, 5. 43 is showing on the thimble. Therefore, add, 43. The total sum adds up to 56,93 millimeters. You should by now be getting the idea. So why don't you see how much you've already learned? By measuring typical components for which you can obtain the manufacturer's sizes. When you are able to consistently obtain the identical readings, even after an anvil change, then you can say that you are 100% accurate. And that is what precision measuring is all about. 100% accuracy every time you take a reading. You can learn more about precision measuring